Okay, the third one in the series, binomial probability distributions, and we have the same goals. We're looking at binomial situations, parameters NPQ, or 1 minus p. Using the values of the parameters, we're trying to determine probabilities and do a bit of mild problem solving. The question's fairly easy, the third one's a bit harder. And for reference, you can see once again we've got the formula and the binomial theorem expansion. So we've got a situation, probability that a person currently in prison has ever been in prison before is 0.72. Find the probability that of the last 5 prisoners chosen at random, at least 3 of these have been in prison before. Correct to 4 decimal places. Okay. You can see we have the important key phrase there, at least. So at least 3. So at least means 3 or more. Okay, so the parameter x is 3, equal to 3 or more. So more than or equal to. Okay, so greater than or equal to sign is what we use there. So in general with this distribution, we have, using the parameter x, we will have this, for each term we'll have this pattern here using our formula which we've looked at in the last 2 videos, this one. So we're going to go from 0 through to 5 because we have 5 prisoners and n equals 5 in this case. Okay, and so that should be fairly self-evident based on what we've seen in the previous videos. The twist, I suppose, and it's only a very mild twist, you should expect to get questions like this, is how do we determine, what's our pathway to determining x is greater than or equal to 3? Well, in this particular distribution, it's the probability that x equals 3, or it could be 4, or it could be 5. So we have to add those separate probabilities together. And so it's essentially 3 of the prior task rolled into 1, and we get 0.8624. That's by hand, and technology, using a TI Inspire handheld or software, you can literally enter that straight in. Okay, and you got the parameters there, n, p, x, and we've got apparently another parameter, but what's happening is that we're using binomial CDF. Now that's significant. It's a cumulative thing, so C means cumulative, which means it adds from the lowest relevant one up to the highest. Okay, so it's a sum. That's in contrast with what we saw previously, which was PDF, which was an exact single value, exactly one value. This one is a ranges from all the possible ones from 3 through to 5, and this is discrete, so it's 3 or 4 or 5. Okay, and using the filling in the parameters method of doing it instead of typing it straight in, we go menu, probability, distributions. Okay, whoops, it's a little bit sensitive there. So probability, again distributions. Just want to tap, there we go. Binomial CDF, okay, cumulative, C for cumulative, and we put in our values again. The lower boundary was 3, so 3 through to 5, okay, and you can see just in the corner. Okay, just hit return a couple of times there just to make sure you can see it. Perhaps my image is in the way, 0.8623 or 24 if you round it. Another possible variation is if there's a situation involving conditional probability, which may occur sometimes. And just as a throwback there, this says probability of A given B, and that's the probability of A intersection B over probability of B. Now intersection is synonymous with the word and, okay, it's in both sets, or it it's something that this is possible and that is possible. It's got to be both. Okay, so and it's got to satisfy both identities or both conditions. So here we have one such thing. The probability of netballer scoring a goal is 0.3 from the probability that out of 6 attempts in total the netballer scores. That's exactly 4 times, and that's 4 times given. There's the conditional probability there, given that she scores at least 1. So you could use technology if it's a tech active question. I'm going to do it by hand. I'm going to assume it's a tech free question. Writing down the relevant information there, and for exactly 4 times we've got the binomial probability formula. We've got 64 times 0.3 to the power 4 times 0.7 to the power 6 take 4, which is 2, and if we crunch that we get 0.05953. So when I say it's tech free, the technology obviously needs to be used for, in this question anyway, for number crunching, but we don't use the binomial CDF in this one if it's a tech free. If it's a tech active, go ahead. So 4 times given that she scores at least 1, so that's A given B. So we have to translate that into the world of maths, and that would be written such that we have x, so that's meant to be in uppercase, x equals 4, given that x is greater than or equal to 1, because she scores at least 1 goal. That's the given part. Okay, and now we're going to apply the formula. So that means, translating that further, that means the probability of x equals 4, and to me that means x is greater than or equal to 1 as well. I have the probability of b, which is x is greater than or equal to 1. Now looking at the numerator of what we've just written here, x equals 4 and x is greater than 1. What condition or conditions satisfies both? Okay, the intersection of that, well, it's only x equals 4. So that's the same as saying the probability of x equals 4 in a more simple way. So the second condition is actually irrelevant or redundant. You might have heard that before in this case. So it goes away. Okay, so on the next line, we've subbed in the numerator already because we found that in part A. The denominator, it's much easier to use. If you think about it's 0 to 5 in this distribution, we could just add together all the parameters for x equals 1, x equals 2, x equals 3, x equals 4, and x equals 5, alright, but it's easy to just use a complement. It's one take away the one that's not included, which is x equals 0. So use the complement when it saves you work. Okay, putting in the corresponding values, and we basically have 0.0675. Lastly, here's a routine one. A less routine one. It's a little bit more challenging, and we've got the probability of an Olympic archer hitting with the arrows the center of a target is 0.7. What's the smallest number of arrows he must shoot? So that's a bit of a difference, isn't it? What's the smallest number? So that's an inequality we're looking at, and we're not finding the usual parameters. So the smallest number of arrows he must shoot to ensure that the probability he hits the center at least once, so there's another inequality, is more. There's another inequality, more than 0.9. So we're working on a probability of greater than 0.9. Whoa. So we've got the probability of a single Bernoulli success given as 0.7. and the probability overall is greater than 0.9, so the capital P. Now the parameter here is x is greater than or equal to 1 because it says he hits the center at least once. Okay, so whoa, that's different to what we've been doing, isn't it? Now, like we saw in the previous example, we can use the complement in this situation. Okay, just as we did a moment ago in the previous example. Now, it's about time we looked at more specifically what we're trying to find. We're trying to find n, you see. That's what we're looking for. How many arrows must he shoot? That's the total number of trials. So when we get to this third line here, when we're subbing the values in, all we can put in there is n. Okay? And likewise, because we're looking for n, that's going to figure here, we've got n minus r. Oh, it doesn't like that. Now, in this particular case, you can see there, orange underline. Here for this part of it, r equals 0. Okay, so it's a number of successes. We're taking the complement of that, okay? And that will appear there, and that will appear there. So time to simplify that now. Have you noticed that NC0, doesn't matter what n is, has a particular value? If we look at it fully by hand, n minus, so it's n factorial over 0 factorial times n minus 0 factorial, which is just n factorial. And that's 1. So this element here, when it's 0, will come out as 1. So that's 1.7 to the 0 is also 1. And we've got 0.3 to the n minus 0, which is just 0.3 to the n. And that's got to be greater than 0.9. Tidying up further. So we have 1 minus 0.3 to the n on the left side, which has got to be greater than 0.9. And generally speaking, with inequalities, you might remember to deal with solving involving those just like an equation, provided we're not multiplying or dividing by a negative, and we're not. So we could rearrange that equation as we would with an equation. It's an inequality, so we're rearranging the inequality. And then we're going to apply logs to both sides. So rearrange, simplify, logs to both sides. From your previous work, you should be familiar. It doesn't matter what base you take the log to, provided you've got a calculator to crunch that. Now it's log law 3 there. So we get an answer there, and n is greater than 1.91249. So we're talking about discrete integer values. So the minimum number we would need is 2. For this case, it would have to be 2. So the smallest number of arrows is 2. Smallest number of shots is 2.